In this question, it is given a suspended bar system consists of two cross sections as shown in figure. Initially, its lower surface is 0.8 mm above the ground surface. Determine the reaction of the lower support and the stresses in each section when a load of 40 kN is applied as shown in figure. Take the modulus of elasticity of the material as 205 GPa. This is again the question of bars of composite section, in which we are given with a bar which is 0.8 mm above the ground. So there is a gap and a load of 40 kN is applied. So when we apply a 40 kN load, first there will be a gap filling between this system, and then the stresses will be developed in the material. So stresses will be developed in the material when this gap will be filled. So after filling the gap, there will be reaction developed at lower end as well as upper end. So we have to find these reactions, what reactions we will develop at lower end and at upper end. And also we have to find out the stresses developed in this part and this part of the section. So two parts of the section we have to find out the stresses as well as the reactions at lower and upper end. So let us solve this problem. In this numerical, there is a bar of composite section like this. This is in vertical direction. There is a bar and it has two sections, 1 and 2. And there are rigid supports between these. And there is a gap between this, right? And the 40 kN force is applied at this bar, at this section of the bar, right? When the force will pull this bar, this gap will be filled, and then there will be reaction developed from inside, and also there will be reaction developed from the upper end of the rigid support, right? We have to find out the reaction at lower end, reaction at upper end we can find out if we want to find out, and also the stress developed in this section of the bar and also in this section of the bar, right? Also we have given the area 80 mm square and 160 mm square, and we have to fill this gap first. And so here you can see here the total deflection in the bar will be 0.8 mm. There is no other deflection. There will be 0.8 mm total deflection will be the bar, and length of the bar is given. Each section of the length is given. Also the modulus of elasticity of this material is also given, right? So how to solve this question? Basically we want to find out the reaction. If you are able to find out the reaction, you will be able to find out whatever you want to find out, right? So first of all, break the bar into three parts. Say it is A, is a B, and this is C. So we can, when this gap is filled, there will be a reaction from inside. Suppose the reaction from inside is, we can take any direction. Suppose I am taking this direction, RL, and E was given 205 GPa. When this C part will touch the rigid supports, there will be reaction at the lower end, that is RL. RL means reaction at lower end. And there is also reaction at upper end, RU, I am saying it, RU, right? So these are the reactions when this touches this lower part, right? So we can break this bar into two sections separately, and we can find out the forces in each part separately after the 0.8 mm gap is covered. So these are two sections. So we can start from any side, from RU or RL, because A and C part are not shared by any other part of the bar, but B is common to two parts. This is A, B and BC. So B is common to this, and A and C are separate to each other, right? So we can apply a force of reaction here, RU at the upper part, and this is not common to each other, so that's why RU will be the reaction at this part. Now for static equilibrium, if this is force here, then there should be a downward force so that this body will be in static equilibrium, so RU force will be there, right? So at B we have applied the reaction force RU in upward direction and downward direction, and the body is in static equilibrium, the forces are equal, right? And this is tensile in nature. Now the total force at B is 40 kN. what force should be applied at this part of the B so that the combination of this and this should be B in downward direction. So we can apply a downward force of 40 minus Ru 40 minus Ru in downward direction, so that the B part may have total force of 40 kilonewton at this part. You can check here, force at B, FB will be equal to Ru downward plus 40 minus Ru downward. So this is Ru downward positive, this is Ru downward negative. It will cancel out and you will get the total force on FB. By solving this, you will get 40 kilonewton downward. So this is the total force we have applied actually, right? So this is correct. It means we have applied 40 minus Ru downward. And for static equilibrium, there must be some force 40 minus Ru upward, so that the body should be in equilibrium, static equilibrium, right? So it means, and the downward and at lower reaction, the lower part, the reaction is RL. So RL must be equal to 40 minus Ru, right? So RL must be equal to this force, because RL we have applied here and we have got 40 minus Ru in terms of upper reaction. So RL must be equal to 40 minus Ru. So one equation you have got that RL is equal to 40 minus Ru, or you can write Ru plus RL is equal to 40. This is the one equation. And we have two unknowns, Ru and RL. Now we have got the forces here and here. This is tensile here, this is compressive here. Now our aim is to find out Ru and RL. What will be the second equation? Second equation is the compatibility equation. Compatibility equation states that there is total deformation in the bar is 0.8 mm. So 0.8 mm is the total deformation. So what is the total deformation in terms of forces? So due to Ru there is some deformation, due to this there is some deformation, and total deformation is 0.8 mm. So we can write, this is our first part, this is our second part, that total deformation delta L will be equal to deformation due to 1 plus deformation due to 2, and that should be equal to 0.8 mm. 0.8 mm. So use this equation, compatibility equation. Ru is tensile, so we can write Ru, and the length of this part is suppose L1 upon some, the area is given 80 millimeter square, so A1, and material is same, E is given, so say it is E1, E or E1. So this is the delta L1, right? We know the formula for delta L. Delta, you should remember always the formula PL upon AE. This formula should be remembered always, PL upon AE. So Ru L1 upon A1E plus, this is compressive basically. This is compressive, right? So for compressive we have to take the negative. So negative of 40 minus Ru. So it means for negative will come here, right? So I am writing here negative into L2 by divided by A2, area of this part, multiplied by E, and that should be equal to 0.8. We are taking in mm, millimeter. So L1 and L2 we will take in millimeter. So now again we will find out that here from here, now here only one unknown is there. So we can write Ru multiplied by L1. L1 is 1.2 meter. And we can write in millimeter because our answer is in millimeter, because we are taking deformation in millimeter. So we can take 1.2 meter as 1200 millimeter. So 1200 upon A1. A1 is millimeter square, we can convert into meter square. So 80 multiply 10 to the power minus 6. This is our area. E is 205 gigapascal, multiplied 205 gigapascal, multiplied 10 to the power 9. So this is our first equation, this, right? Minus 40 minus Ru, multiplied L2. L2 is 2.4 meter, means 2400 millimeter, divided by A2 is 160 millimeter square. So millimeter square can be converted to meter square. Meter square is 10 to the power minus 6 meter square. And E is same 205 gigapascal. So 205 gigapascal is 10 to the power 9. And that should be equal to 0.8 millimeter, and we have taken meter into millimeter. So this is the equation, compatibility equation. Now there is one unknown here only. What is the unknown? Ru, the reaction at the upper end. So Ru, when you solve it, there is one unknown. It can be easily solved through calculator, and when you solve it, you will get the answer 25.5, right? So you will get Ru as 25.5 kilonewton, right? And it is positive. It shows that the direction chosen by us was correct because it is positive. So we have got one reaction, Ru. RL can be obtained from here. RL can be obtained from here. This equation, one equation. So from one, we can find out RL also, the reaction at the lower end, and it will get it 14.5. Because total sum is 40. Sum of the two is 40, so you will get answer 14.5. So RL you will get as 14.5 kilonewton. So this is one of the answer. This is one of the answer that we have to find out the RL. So we have found out this RL, the reaction at the lower end. It is also positive, so that the reaction, the direction chosen by us was correct, that this is upward direction, right? So this direction is upward. RL is upward. Reaction is in upward direction, right? So it is correct now. Now we have to find out the stresses, and we know the forces acting on these two parts. The force acting on this part, one is Ru, and this is tensile. So reaction, the stress in one will be equal to this tensile stress, force upon area. So this will be equal to Ru, we have already obtained 25.5 kilonewton divided by this much Newton. Area is given to us 80 millimeter square. If we use directly 80, the answer will come in megapascal directly, right? Because millimeter square is 10 power minus 6 meter square, and 10 power 6 will go in numerator, and that will become megapascal. So we are writing 80 only. And solve it, you will get the stress in the upper part, this part, first part, and you will get 318.3 megapascal. So sigma 1 is, we have got another answer as sigma 1 is 318.3 megapascal. This is one of the another answer. The stress in upper part of the bar, this section of the bar, sigma 1. Now we want to find out sigma 2. Find out the sigma 2. Sigma 2. What is sigma 2? The force acting on sigma 2 is compressive. This is compressive. And how much compressive? 40 minus Ru. So 40 minus Ru is the force acting on sigma 2. So sigma 2 will be equal to force upon area. So 40 minus Ru upon area, or RL. This is basically RL. Upon area is A2. So 40 minus Ru is basically RL, 14.5. So 14.5 is the force multiplied by, and this is compressive, multiplied by 10 power 3, it will become Newton. Upon area is 160. So you will get the answer. The stress in part 2 is 90.8. Solve it and you will get 90.8 megapascal. So sigma 2 is 90.8 megapascal. This is the last answer of this question. So very easily you have found out, you have broken the parts into two parts, and you have obtained the reaction at two parts, and finally you got the stress and reaction at the sections of the bar.